Hello guys, welcome back to a new video. And in today's video we have got a very important topic that is relatable to the chemistry and physics as well. Now the topic name is the diffusion and effusion. These are basically two different phenomena, and in this video we're looking into what are they, and in upcoming videos we will be looking into a law related to it, that is the Gram's law of diffusion and effusion. So we will be understanding it with the help of diagrams. I'll be making you uh, super duper clear. So without wasting time, let's get into it. Now for diffusion, I've got a diagram for you guys. First of all, let me tell you that the topic is diffusion. It is derived from the word diffuse. Diffuse means to expand, right? To expand. Now, if we talk about the basic definition of diffusion, that is the process by which uh, molecules from a region of a higher concentration escape toward the lower concentration. Now, we need a diagram to explain this, and there is a beautiful diagram. Uh, here is a simple definition written in diagram as well. That is movement of particles from a region of higher concentration to a region of low concentration. This is a universal law that some everything will move from a region of higher concentration to a region of uh, lower concentration under ordinary conditions. Now, if you can see here, uh, like here, if there is example given, what you do is that you take some ink drops and pour them into the water bottle. Then see the place you have just poured over here. This is like over here, slowly, like here. See that the point which here you dropped is higher concentration, right? Here you have dropped a point over here in this surface, and here is a higher concentration, and these are the water molecules, and these are the dye molecules and the ink molecules. Now you will see that slowly the movement towards the lower concentration. In the center there was higher concentration. Now this is moving toward throughout the bottle. That means that it has covered now this much area. Now this shows that the ink particles moving from higher concentration to the lower concentration. Now this is diffusion. Diffusion is simply the movement of particles from a region of higher concentration to a region of low concentration. And this is happening over here. Now if you can see in the next picture, diffuse evenly equilibrium. Now the result of diffusion is this: the water and the ink molecules will equally distribute. They will get into equilibrium, the balanced state. Like there would be no any higher concentration of lower concentration. There would be equal concentration of the ink and the water. So I do hope that you have got the concept. That was quite easy as well. Uh, I can give you a trick that diffusion happens in large areas. Like this is maybe not written everywhere else, but I'm telling you, like diffusion is the one which is happening in the open area, or like we have got a full jar box. We are not limited to this part. So diffusion is the one which is happening throughout the container, or throughout the surrounding, or throughout the place which you are telling. We will be discussing the more examples of diffusion and effusion that will make you guys more clear about it. Then I will repeat the point again for you. Now here we have got the effusion, and this is even more easier, but it's less common than diffusion. Effusion, right? So here you notice we have got a container C, and here we have got a hole W. uh, Now you're gonna see, if you're gonna see the size at a single time, one can travel. Now what happens in effusion is this: there is the movement of the molecules from a region of higher concentration to a region of low concentration, but the place is very limited. We have made a small hole, and the particles move throughout the small hole, and in this the particles, the atoms, the molecules are in contact with each other. Now like this will happen. This will get back to it, then this will go, and after that this will go, after that this will go. Like there is a line being followed. The one particle would be here, and one is over here. They are all connected, and they are traveling line by line. Like one is over here, one is over here. This is happening in the effusion. Like we have got a limited distance, and among between that distance the molecules have been traveled. They are in contact with each other, and uh, and there is a clear difference. Like uh, let me take razor to make you guys more clear. If what I do is this, sorry, I cannot use this one. Let me use this thing. If I rub this part, this line over here, now the movement will diffuse, because I have told you, Rick, that diffusion will be taking place from uh, throughout the surface. There would be not a limited surface. So now this is effusion, but now I get back the line, so this becomes diffusion, right? So I do hope that you've got the concept. Now let's get into more diagrams to make you more clear. Here we have got a beautiful perfume. I don't know what the company it is, but let's understand the concept related to it. Now when you see, here is a small hole in the middle of the perfume. Now, as I told you, the the movement of the particles from region of higher concentration to region of low concentration through the small hole is termed as effusion. So this point, effusion is taking place. As the perfume is out, it spreads out throughout the surface. There is no any limit. So here the effusion, so here over here the effusion is taking place, over here the diffusion is taking place. We have got the both phenomena over here. Now I do hope that you are linking the both things. If you can see here, this tire is not puncture, but you're gonna see there is a small hole over here. Now there is a small hole. This means the effusion is taking place slowly. The air is getting out. Let me tell you, in the diagram here, you're gonna see there's a tire burst, and this is diffusion. There is no any single hole. The single hole will be here, but here there is full tire blast, and this is a diffusion. Because diffusion is happening throughout the surface. There is no any, this will not take time. This will suddenly burst up and diffuse into the air. Now uh, I do hope that you have got the concept. There was one wonderful diagrams I have shown you guys. uh, if you do like if you understand the topic, do like the video. Meet you guys in the next video. Till that, goodbye.